Welcome to our second lecture, our Wednesday lecture of our fifth week. Today I'm here in the hot seat and Mairead is going to be online to answer any of your questions. So make sure to keep her occupied. She hates having nothing to do. So without further ado, let's get started and we'll see what we've got to do, and hopefully we can finish on time today. Because as you know, on Monday I didn't get everything finished. So what we're doing is I'll just spend a little bit more time on what we didn't get finished today, because we do kind of go back over it. So we'll spend a little bit more time making sure that we go back over the constructors and the difference between the default and parameterized constructors and what is overloading. Okay, so let's get going. So hopefully you can hear me. I'm just going to just check to make sure that you can hear. Okay, I think we're good to go. I don't see anyone giving out to me, so I'm hoping I'm not on mute, and I don't look to be on mute, so that's good. So today we're going to have continue with our classes, and we said on Monday that we were moving away from the procedural style of programming that we were using, and we were really going to start programming an object-oriented style, and from now on, and that's exactly what Java is. It's an object-oriented programming language. So we're going to really start everything that we're going to do now. We're going to create in classes, and we're going to create objects from those classes. So today we're going to look at adding behavior to our classes. So that's what kind of do all the verb things that we think of. So if we're talking about me as a person, my behaviors are jump up, sit down, talk, walk. So they're all verbs. So that's what we're going to look at add today to our classes. All the behaviors of our class, all the things our class can do. Okay, and we'll just have some simple examples. And you'll notice that they're methods. And you've already done methods, you already know what a method is, you already know that it's something that does something for us, and we can pass it values to help it with what it has to do, and it can return values. So that's what the behaviours of our class are. So we'll have a look at those in more detail. So today we're going to continue on with our bank account. We're going to have a look, as I said, at the behaviours, and they're the methods that are associated with our class. We're going to look at our constructors again. So on Monday we started by talking about what the constructor was, and we said that a constructor is a method that's called when an object is constructed. So it's how it's going to be constructed. It's, do we pass it in information, or is it a default and it has default information? So again, we'll look at those again today. So we look default on Monday, and we're going to have a little bit more look at the parameterized ones today as well. The behaviors that we're looking at, we're going to look at methods to deposit money. So it's always good to be able to deposit money into your bank account. So we're going to be able to look at how would we write that, where would we write it, how do we call it, etc. How do we withdraw money, which is all I seem to ever do from my bank account. So my bank account definitely knows how to be withdrawn from. But we're going to have a look at where we write the code, what it does, and how we invoke or call that method. We're also going to look at display, so just a display method. So how to print out what's in our bank account. And finally, we're going to have a look at arrays of classes, so array of objects. So before we were looking at arrays, and they were all primitive arrays. We did, briefly have a look at an array of string, which is a class. But today we're going to have a look at arrays of our objects. So, we're going to have our bank account objects and how we would access those. Okay, so a lot to do today. So just a reminder before we get started on what we started with on Monday. So we started with our bank account, and this is going to be our worked example for today. What we're looking at here is your UML. So we can see up top it has a name, so that could be our class name. Then we have our fields, and we said this is the information of the data about our bank account, so what was going to be stored. So you can see that we have a field called name, which is a string. We have a field called account number, which is also a string. And we have a balance, which is going to have hold a number with a decimal point, and that's a double. So there are fields, other name is our attributes of our class. You also might call it instance variables. So you might hear that word being mentioned, or that phrase being mentioned, instant variables. So fields, instant variables, attributes, they're all the data that we're going to store about our class. Our methods are our behaviours of our class. You can see there we have the two in bold, and that's bank account, and there are constructors. And we said they were a particular type of method, a special type of method that has the same name as our class, and it doesn't return anything. And they are invoked, or they are called, when a new object is created. And again, we'll go back through those again. So the methods are our behaviours of our class, what our class can do. And you can see here in our bank account, we have bank account and bank account. There are constructors. Then we have deposit, which we're going to pass it a parameter, which is going to be a double. We're going to have withdraw, and we're going to pass it a value, which is a double as well. And then we have this other one called display. So if you were given this to do, you would be given that UML and said, okay, this is what you have to model, or this is what you have to create. And then for the methods, you would be given information as to how you would write them. Okay, today we're just going to assume to deposit money, we're putting money, we're adding it to the balance. To withdraw money, we're making sure that the amount is in the bank account and we can take it out. So we can't try and take out €1,000 if there's only 500 in it. And in our display, it's just going to be print out the details or return a string. Okay, so we'll get to those today. So again, follow it on from Monday. We're going to take that bank account and we're going to improve on it and make it work for us. Okay. So on Monday, when we looked at the bank account at the start, we looked at a piece of code, and in that piece of code we didn't have a bank account class, and it was procedural. We created variables that were going to store the values, and then we said, you know, if we have one bank account, which was our Elon Musk guy, and that was fine to create these variables, but if we have 1,000 or 10,000 or 100,000 bank accounts, are we actually going to create 100,000 variables for a name, 100,000 variables for a balance, and so on? And then we said no, because the best thing to do is to create a class. The class has all of the information in it that we need, and then we create objects of that class, and we can create as many of them as we want. And we talked about how the class was the blueprint. So we're going to have a look and just go back over what the class was, just to make sure that everyone is okay. Okay, I don't think you really need me there. So what is a class? So a class defines a group of related fields, so information about the class. So variables, properties, attributes. So I mentioned the word instance variable earlier on. So that means that for this object, these are the variables. So variables, properties, attributes, okay, they're all words that we would use for our fields. Our methods, so functions that manipulate those fields or do something. I mean, in most cases, they manipulate the fields. They don't always have to, but we will get to that in a while. But for now, our methods are going to interact with our fields in some way. An object, so the object is a single instance of a class, and an object is created from a class. So we said on Monday, the class was the blueprint, so the class was the design for the car. So the car was going to have a name, a number of wheels, a colour, all of those good things. And then the object is created is when the car was created. So a blue Morris Minor, a yellow Audi A4, whatever it was. So the object is the instance of the class. Many objects can be constructed from a single class definition, and that's so important to remember. When we create the class, we can create as many objects from that class as we want. And we had an analogy of a cake, and the cake is like a recipe for, a class is like the recipe for a cake. An object is the cake baked from that recipe, and you can bake lots of cakes from a single recipe. Okay, so just to remember, when we design our code, when we write our code, when we write the class, that's the blueprint, and then we can create as many objects based on that as we want. So good things that we have to remember. So the class name, so when we're naming something, we want to make it so that we understand what the class is all about. So it should match its purpose. So if we are creating a class for a bank account, well then, hey presto, bank account is a pretty good name for that class. So we always want to name our classes in a way that makes sense to what they're doing. So it can be any word or words, but it's only one word. So if what that means is you can have more than one word, but there's no spaces between them. And we talked about that being camel case. So it should begin with a capital letter, and it should not be pluralized. So no apples, it's apple. And then we can create many apple objects from that, but the class is apple. The class is bank account, and you can see here we have our capital B and our capital A, and we said that was our camel case. When we have other words inside, we capitalize those. We looked at a class of apple, and we said that our class name was going to be apple, and it had fields of colour and weight, and there are its attributes. And then for that apple, it can grow, it can fall, it can rot. And every instance we create from that class will have its own value for colour, its own value for weight, and it will have its own ability to grow, its own ability to fall, and its own ability to rot. Okay, so you can see here that this here is our class. When we create objects from this class, or instances, depending on what you want to say, that's when in memory it creates a space in memory that's going to have its own value for colour, its own value for weight. So our object here is our Gala object. It's red, its weight is 6.2. This is our Golden Delition object, and its colour is yellow, and its weight is 8.4. So there's two instances of our apple class, and each instance has its own name and its own copy of the fields. And that's really worth noting at this moment in time. When we create the class, we're kind of saying this is the information each object is going to store. And then when we create an instance of that class, our object, it has its own values for that. We talked about the dot operator on Monday, and we said the dot operator was like saying of. So when we had the property of the object, so the name of the apple object, the colour of the apple object. So our dot was how we accessed those properties and also those methods. So we had to say which object for which property. And again, we're used to doing this. If you want Siobhan to answer your question, you'll say, Siobhan, answer my question. If you want Mairead, you say, Mairead, answer my question. So we're used to being able to identify which object we're talking about. And in coding, when we want to access a value or a field or a method, we use the dot. So you can see here that the object is Gala, and we're getting the field colour. So give me the colour of Gala, so that's where we have our dot. So this gives access to the colour value in the Gala object, and the colour value in the Golden Delicious object. So our dot operator is really important in that it allows us to access the fields and the methods of our object. When we're calling our methods, it's the object name, dot, and the method. So this invokes the grow method inside the Gala object, and Golden Delicious.fall invokes the fall method inside the Golden Delicious object. Okay, again, I'm going to show you examples of these. So this is kind of the terminology, and then once we get in and show you some examples, it'll make sense when we're using our dot. Okay, so on Monday, when we were doing this, we got as far as version 1, and then we didn't get any further because we ran out of time because I talked too much. So hopefully today we can get through everything, and we'll be able to finish on time. So I'm going to take a little bit of time going back through the constructors, just so that we're all aware of what they are, because it's so important for you as developers to know, what it means to construct an object. So we're going to start with our bank account one, as we did on Monday. I'm going to use the code. I should have opened it beforehand, but I didn't. I'm going to use the code that we started with on Monday, and we'll just build on it. And when you're doing it at home, you'll be able to build on it as well. So we started with version 1, and we said that we have a bank account, and this is our class, and it has a name, an account number, and a balance. So this is going to be the data that we're going to store for the bank account. So we define the class by using the keyword class and giving it a name. Remember, our curly brackets are really important. So our curly brackets tell us that whatever is inside this curly bracket and this closing curly bracket, that's the class. That's all of the information about the class. And in here we declare our fields inside. We're also going to write our methods in there as well. So this is our opening curly bracket for our class, and this is our closing curly bracket for our class. And inside that we'll have all of the code that relates to that class. So all of the fields and all of the methods. So we said in IntelliJ we're going to place this code in a new Java class called bank account. And you can see here that we're going to create our bank account.java class. Okay. So we started off with our version 1, and we didn't write a constructor. It had one by default. So what that means is if we don't write code for how each object is going to be constructed, Java automatically writes one for you. We don't see it, but it's there. And it gives its own values to our fields. So for names, for strings, it'll give the null value. For numbers, it'll give 0, etc. So this was our main, and we can see here that we're creating a bank account. We called our constructor, and we said our constructor was what is called when we create our object. So that is going to create the object in memory. If we don't pass it parameters, which we're not here, it's going to create the field, whatever the account number, the balance, with some default values. Then here in our code, we're calling that object that we've just created, and we're calling the field name, and we're saying make the name of bank account 1 equal to Elon Musk. Make the account number of bank account 1 equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Make the balance of bank account 1 equal to 1500. So here's where we have our dot. So we're saying the name of bank account 1, the field account number of bank account 1. So in memory, let me see, where's my pen gone? my pen doesn't want to come out. Oh, let me see. There we go. So let me have a look and see. So in memory, this line here creates the object bank account 1. So that's this guy here. And this new bank account, what that does is it constructs it in memory. So it creates our object, and it's going to have our name, our account number, and our balance. I should have made that bigger, shouldn't I? Okay. It's creating this in memory. If we go back to our class, we can see that we didn't create a constructor here. So therefore it's going to use Java's default one. So when it uses Java's default one, it's going to make the name null, the account number null, and it's going to make the balance 0. Because that's what the constructor does. Java has a default constructor, and that default constructor, if we don't write code for it, it just gives its own default values. Then here we're saying make the name field of bank account 1 equal to Elon Musk. I'm only going to write this one in because I know it's looking a bit messy. And that's when we're placing the value Elon Musk into our name. So this line here creates our bank account object, and when we call our new keyword, it constructs that object in memory and it gave it default. And then this line here is putting the name Elon Musk into our field name. It's going to put the account number 1, 2, 3, 4, 5, 6, 7, 8, 9 into our account number, and it's going to put the balance 1500 into our balance. So this is how we're accessing those fields or updating those fields. Okay, so that's our declaration. It's when we're calling the constructor to build that object in memory. And remember, if we haven't written a constructor, it's going to give us one by default. And then this one here is where we're initializing the fields with starting values. So we use the dot product with the fields in the assignment statements. So we're saying put the word Elon Musk into the field name of the object bank account 1. And down here we're updating the balance, because as of yet we haven't written the methods. So the bank account class doesn't know how to do it by itself. So we're writing the code for it. In a few minutes, we'll have one of the versions will write that code for us. Okay, so you can see here that we're interacting directly with the balance. This morning on Slack, somebody asked a really, really brilliant question around making our fields private. And it's not something that we have discussed at the moment, but we will be discussing it next week in encapsulation. Here we're accessing the fields directly. And that's because we haven't declared them as being private over here yet. Good programming practice would tell us that we shouldn't do that. So we're doing that now just to show you how we access those fields. Good programming practice would tell us that we would hide the data from other classes and we would make those fields private. So if you're doing this yourself in the exercises, see what happens when you declare the fields as private. Can you see those fields from another class? And if you can't see it, why can't you see it? And how would you fix that? And we're going to tell you how you fix it is by having public methods. So you'll only be able to access the private fields through a public method. And again, that's coming next week, but it was a really good question and shows that you're really thinking about how we're going to write our classes, how we're going to write our data, how we're going to hide our data, and how we're going to access our data. So it's really good. So this is our version 1. Okay. So you can see here when we declare our object, it creates our object, and it's only when we call our constructor that our object gets constructed in memory. And you can see it initializes our fields with null and the balance with 0, because that's what Java does. It gives them default values if we haven't declared the default values. Okay, so the bank account one is our object, and it's constructed with the new keyword, and in memory it's going to build bank account one as the object. So a constructor is a method that has the same name as the class but no return type. Its job purely is to construct the object, and a default constructor doesn't need any information. It's going to do it from it's going to give them default values, and we're going to have a look in a second at passing it information, passing it parameters. So if you don't include a constructor in your class, the compiler inserts a default one for you. So you won't see this in your code, and you don't need it if you don't create any more constructors. So this one here, if you include it, that's fine. But all it's going to do is it's going to make that null, and the balance of 0. Okay. So that's our default constructor. Our default constructor doesn't take any information, and it gives our fields a default value. So how we want them to start out. So that's fine if we want to do that. But we've talked about how a constructor is used to create and set up an object. So I suppose think of it as a setup checklist that runs automatically whenever we create a new instance of a class. So it gives the initial values. But sometimes when we create a new object, we have different amounts of information available. We don't always have no information available. We sometimes have some information. So for example, for our bank account class, sometimes we might only know the customer's name. Other times we might have their name, account number, and their starting balance. Or we just might have create a blank account for testing or whatever it is. So at the moment, we've just started with the blank account. So instead of focusing on one constructor to handle every possible situation, we overload constructors, meaning that we write several constructors with the same name but with different parameter lists. So the different parameter lists will model the different information we know at that moment in time. So again, we're going to have a look at that in a second, and we'll go through it. So each one of our constructors will produce a valid bank account just with different starting information, and we'll have a look at that. The big advantage here is flexibility. You don't always start with the same data. When the system first creates an account, maybe we don't know the balance, and I've already said that, so we use the simple constructor. But let's say, for example, PTSB or whatever it is being sold at the moment. When those accounts are being moved into another bank, well, all the information is known. And when we want to build the accounts in the second bank, well, then we'll need a constructor to build it with all of the information, because all of the information is there. So like when we're loading existing customers from a database or from a flat file or whatever, we could use a full constructor which knows all of the information. It makes our code cleaner and more readable, and instead of creating an empty account and calling a bunch of setter methods, which is kind of what we're doing back here, where's it gone? You can see that we created it with no information, and then we called all of the fields one by one, and we gave it the information it needs. But if we knew that up here, well, we could have passed it in here. So it makes it cleaner. So instead of having 4 lines of code, we'll have 1 line of code, so it'll look neater. Okay. So when we start off in our bank account, if you think of the analogy, if you're opening up a bank account, sometimes you might walk into the bank and you don't have all of your information at hand. So you might just go in and say, I'm opening up an account, this is my name, I'll come back to you with everything else. So they might only open up an account with your name, and then you'll come back in with the money, and you'll come back in with all of the documentation. Or sometimes you can be like Mairead, who's super organised, and you'll arrive with all of the information that you need, and the person who's behind the counter can set it up correctly with all your balance information there and then. So you can see in the real world, we construct accounts, we construct our accounts differently depending on the amount of information that's known at that moment in time. And that's the way we're going to write with our constructors. We write our constructors with the knowledge of what is known at that moment in time. So we can write a number of different constructors, and the correct constructor will be called depending on what is known at this time. So for this constructor here, we're going to write a constructor, which is our bank account here. So you can see here that it's public, and we said it's public because we want to be able to see our method outside of this class. This is how we're going to access our fields. And again, next week when we start anti-data hiding, you'll know that our methods that interact with our classes are going to be public. So it's public. It doesn't have a return type, so there's no return type there, and it has exactly the same name as our class. In this case here, we're going to pass it in 3 pieces of information that we know. So when we're setting up this time the bank account, we'll know the name, we'll know the account number, and we'll know the balance. So we'll pass it in a string, which we're going to call NM, a string, which we're going to call account number, and a double, a number with a decimal point, which we're going to call BAL. And we're going to take that name and we're going to put it into our field that's name. We're going to take the value that we pass in an account number, and we're going to place it into the account number, and we're going to take the value that we pass in and we're going to store it in our balance. So we don't have to do all those individual accessing it like we did in the previous version. Now we're going to call our constructor, give it the information it requires, and it's going to update our account for us, our object for us. So we're going to pass in these parameters. These are just names. So all it needs is it needs to match. So we're going to pass it in a string, which we're going to call NM. We're going to pass it in an account number, a string, which we're going to call account number. We're going to pass it in a number with decimal point, which we're going to call BAL. And then we're going to use those values to initialize our fields, our instance variables for this object. Okay, so now we can call our bank account, our constructor, and we can pass it in the information that it needs. So we're not calling the default constructor anymore and giving it default values and then having to update each field each field one by one. We're now saying, okay, I know all the information at the start that I need to create this object. Here it is, create the object. And our code will go away and it'll create an object in memory that has the name Elon Musk, the account number 123456789, and the value 1500. Okay, and then this code here is staying the same. It has our balance because we haven't got to behavior yet. So you can see here our constructor is constructing our object based on the information it had at that time. Very same as when you walk into the bank. If you have all the information, your account will be constructed with all of the information. If there's only some of your information, your account will be constructed with the information that's at hand. We have to code for that at the start. So we're coding, we're saying when this is constructed in memory, if we have these 3 pieces of information, use those 3 pieces of information to update our fields. So this is called overloading. It's when we have the one method name, in this case the one constructor name, and we pass it different information. So we can have as many constructors as our design requires once they have unique parameter lists. And this is called overloading, and we're overloading our constructors in version 3. Okay, so you can see here that we have our bank account and we have a bank account constructor which takes some values. So that's our version 2, and you can see that this is staying the same because we haven't added in our behavior yet. So we're only at this moment in time in our version 2 looking at how we construct the account. So we're still at the walking into the cashier and creating our account depending on what information we have. So you can see here that we're creating a bank account. We need to have 3 pieces of information: a string, and a double. Okay. So maybe I'll just see, can I open up IntelliJ just for a sec? Okay. So if we go back here. So this here is our bank account. I'm just going to go in and write in our create our constructor for us as well. So on the last day, instead of using the default of Java, which was null, null, and 0, I just gave it my own default. So when a bank account was created, if it didn't pass it in information, it was going to make the name unknown, the balance, the account number 0, and the balance whatever. If I know those pieces of information, I'm going to create a constructor that's going to take the string. So you can see here it's got a red line. That's because it has the same parameter list. So now I'm going to change it. So I'm going to pass in a string. I'm going to call it name. I'm going to pass in a string. I'm going to call it account number. And I'm going to pass it in a double. And I'm going to call it Bal. And then I'm saying whatever values I pass in, I want you to store it. So when it's constructed, I want the name to equal whatever the name I passed in. I want the account number to equal whatever the account num I passed in. And I want the balance to equal whatever number I passed in for Bal. So that now is my constructor. And it's going to expect 3 pieces of information. So if I go back here and I'll create another bank account. So remember, from the same class, I can create as many objects as I want. So I'm going to say bank account, and I'm going to call it BA2 equals new bank account. Remember, it expects a string, and a balance. So I'm going to give it what it expects. So I'm going to give it in our Elon Musk. I'm going to give it in the account number. and it expects a balance. And poor old Elon still isn't doing great at his account. So he only has €889. And now, if I print out okay, and so you can see this one here, I'm just going to change that one to Siobhan so we can see there's a difference. So now when I run it, it's saying, when I created a default at the start, remember it called this constructor, so name was unknown. And then I changed that name to Siobhan Roach, and then I printed it out, so now it printed out Siobhan Roach. And then this time when I created my object, I gave it all the information I had because I knew it all. And then when I printed it out, it had Elon Musk, because it took that name there and it stored it in name. So there are two constructors that we've looked at: our default constructor, which gives default values, or a constructor where we pass it in information. And again, you have to remember that the constructors, when they're constructing the objects, it's because different information is known at that time, and we write our code with, to try and, deal with every eventuality, or as many eventualities as we think we know we have. Okay, so that's our bank account. So now we're going on to our next version is when we're going to create some behavior. So we're going to add behavior to our bank account class. So this is when we want our object to do things. So let's have a look. The first one we're going to look at is display. So far we've only written constructors and fields. Now we want to have behaviors. So this is what our account can do. So we want to be able to print the account details to the screen. So to add behavior to a class, we write a method inside of that class. So the first one, in the first version, we're going to have display on console. Okay. And its job is to print to the console. And you can see here that we'll have a method display on console. It's returning nothing, and it's printing out here. Now that's all well and good, but I want you to always remember that your classes that you write can be used in different places. So they're not just going to be used on a console-based application. They might be used in a mobile app or in a web app. And in those cases, you wouldn't be writing to the console. You'd be printing to the screen in some way. So when we have our system.out.println, we really shouldn't put those into our classes, into our data classes. We should try and only have one class that deals with the input and output, and that's what we were doing with our driver. So even though we could do this, we're probably better off not. We're probably better off returning a string, and then that string can be printed to the console if that's what we're doing, or it could be used to put into a box on mobile app dev or a web app or whatever it is that we want to do. Okay, so this here is one version where we can print it. So you can see here we have our bank account, we have our constructors, and then we have our display on console. And you can see that one there in our main, it's calling this method here. It's invoking this method. So we're calling the method display on console for our bank account object, and it's going to print it off. So it prints directly to the console. And as I just said, that's fine and dandy, but it's possibly not the best thing to do. We should really restrict our input or output to our main or our driver class. So what we're going to do is we don't put print statements in our bank account. In any data classes, we're not going to put print statements because, as I said, these classes can be reused in different projects, and those projects may not all be console based. So we're going to have a class that's responsible for the input and the output. So we will write a method that returns a string, and we'll call this method in the main class, and then it prints out the string. Okay, so you can see here we have our display, and it's going to return the information. So let's have a look at that, because it looks a little bit messy there. So let's have a look at that in our code. So this is our class, and in our methods here, we're going to write a method that's public. It returns a string. It's called display. It doesn't need any information, so we're not passing it in anything. So you'll see straight away we have a red line here. And the reason why is because this method expects us to return a string. So until we say return and a string, we'll have this red line. So what we're going to do is, I can do this two ways. I can create the string, so I can say string details equals, and then whatever information that we want to return. So we want the word name to return, plus whatever value is stored in name, plus the information that's stored in the field name, plus the word account number, plus whatever value is stored in account number, plus the word balance. And we could, if we wanted to, put an euro sign there. Plus whatever value is stored in balance. So we can, if we want, create this string in memory that's going to have all of that information. And then when we have the information together, we'll just say return details. And it would help if I spelt it right. So you can see now my red line is gone. So that's our display method. We built the string and we returned it. In our code, it's only one return. So those two lines is the same as saying so it's the same as saying that. So here we're creating a space in memory, we're calling it details, we're placing this information in it, and then we're returning it. Or we can just do it on the fly and just say return name and whatever it is, and then it's out of there, it returns it. Okay, so this is one of our behaviors. It's our display behavior. And now we'll go back here. Instead of doing that, we can call the display. So we can call the display, so BA1 dot display. We'll call that display, and if we want, we can call BA2 dot display. So now when we run it, and I'm just going to comment that out and comment that out for a sec. You can see it returns the string as we built it, except the first one, BA1, has Siobhan Roach, My account number is 0 because I haven't updated it. The balance is 0 because I haven't updated it. And it also returns Elon Musk's, his name, the account number, and the balance. So you can see that once we wrote it once, we can call it numerous times. And each time it will return the information in the exact same format. So we're not reinventing the wheel every time we want something done. Okay, so let's keep going. So you can see here, this is our class diagram for that version that we've just done, and we have our display. Now what it is actually missing there is it doesn't show that it returns a string. The class diagrams that we will give you will show you the return types as well, and I do have a version in a second that will show you that. Okay, so again, if we want to deposit money in, instead of writing the logic over here in main, we write the logic in our bank account, and then we pass it the lodgement amount and it updates the balance. So all of our logic is in our class. We test it, we make sure it's right, and then it's right for all of the objects that use it. So we're not, as I said, reinventing the wheel every time. So you can see here we create a method. It's public because we want to see it outside. It returns nothing because all it's doing is it's adding in the money, and we're passing in the amount, so a double, that we're going to add to our balance. And that's our deposit. Okay. Our withdraw. So in our first version, we had our logic for our withdraw in main. So that meant that every time we wanted to withdraw from an object, we would have to rewrite this code, which doesn't make sense. So it makes sense that if we put it inside our class, and then we can just call it once. So we want to refactor this method. To do this, we'll write a method that takes the parameter of the amount we wish to withdraw, checks that there's sufficient funds to allow the withdrawal, and if there are sufficient funds, it'll deduct the amount and it'll return the string withdrawal successful. If there's not sufficient funds, then it'll return a string indicating that there are insufficient funds. So it said that it didn't do it. So now we're going to create this withdrawal inside our bank account class. And we're telling it, it's going to call it withdraw. It's going to return a string. It's public. It can be seen from the outside world. We're going to pass it in a value. We're going to call that value withdrawal. So it's just a name that we're given to the value that we pass in. Then we're saying if that value is less than or equal to the balance, then we can withdraw it. So the balance, the new balance is equal to the old balance less the withdrawal, and we're going to return yes, we did that. Otherwise, we're going to say you've insufficient funds. You can't withdraw it. So as you can see, if you look, every time we add to our class, our main looks neater because we're removing the logic from our main. Our main's job is going to be input, output. Give me the information and I'll show you the information. That's all it's doing. All the heavy lifting is being done in our bank account class. That's where we're writing our methods. Okay, so what I'm going to do is I'm going to give you 5 minutes. What I'd like you to do in those 5 minutes is to see, can you draw to write the withdrawal and the deposit one yourselves. When we come back, I'll do that as well, just so you can see that is it working for you, and ask any questions if it's not. So we'll just take 5 minutes. love that sound. I hope you can hear me. I'm not on mute. There's something weird happening with my sound. So hopefully all is good. So let's go back to where we were anyway, and we'll see. Okay, we'll see where we were. Okay, now. So what we were looking, I said to you while you were back in your offices doing nothing, is to try and have a look at the withdrawal and the deposit. So let's have a look and see, can we write the deposit? So I just want to make sure that I write it the right way. Okay, so it's called lodgement. Okay. So again, in our bank account, we're going to create our deposit account. So it's public because we want to be able to see it from another class. It's void, it's not returning anything. The name of our method is deposit. And we're going to pass it in a number with a decimal place. So we're going to pass it in a double. And we're going to call that lodgement. Again, this is just a name. It doesn't mean anything. Java doesn't know that you're trying to lodge money. It doesn't know it. We are giving it a name that makes sense to us. So that's why we're calling it lodgement. And with the lodgement, all we're doing is we're adding it to our balance. So our balance is equal to what's currently in our balance plus the lodgement. And that's the same as saying, which is in your notes, balance plus equals lodgement. So what we're doing is we're saying make the balance equal to what currently in the balance plus the lodgement, and that's the same as saying balance plus equals lodgement. So it's just a shorter way of writing it. So that's our balance. Our withdrawal, the logic for that, remember what it said. It said check to make sure that there's sufficient funds. If there are sufficient funds, take the money away, and then send back a message saying yay, you could withdraw the money. Otherwise, if there's not sufficient funds, let it be known that there's not sufficient funds. There's insufficient funds. So when we write that, you can see that based on what we've already learned, that's an either or situation. So we're going to have an if statement. So again, it's public. Public. It returns a string. It's called withdraw. Okay, I still can't spell. And we're going to withdraw an amount. Does it tell us what we call that withdrawal amount? Okay, so we're going to pass it in a double, and we're going to call it withdrawal. Again, it's just a name that we're given to it. So remember what it told us. It said that you first of all have to check to see, is it valid? Have I got that money in it? So I'm going to have an if statement. So if my balance is greater than or equal to the withdrawal amount, open curly brackets, because I'm going to have more than one line of code that I want to be executed if this is true. So if I have sufficient funds, then I'm going to say balance is equal to what's currently in the balance less the amount of the withdrawal. And remember, that's the same as saying balance minus equals withdrawal. So if the amount is correct, then I can take it away, and I'm going to return something that says, I don't know, successful withdrawal or whatever it is. you can write whatever you want yourselves. And I think I've spelled that wrong as well. There's 2 C's, I think, in success, is there? Okay. So that's my if. If it's not, so you can see I have my red, because there's only one return there and it's inside the if. If this isn't true, I am going to write an else here. I actually don't need to do that, and we'll explain that on a different time. So if the balance was more than the withdrawal, then I can take the money away and I can say successful withdrawal. Otherwise, I'm going to return a message that's going to say insufficient funds. Okay, I know that's not exactly what's there, but you can fix that yourselves. So our withdrawal is going to, we're going to pass it in a number. We're going to check that number. If it's valid, we're going to take it away, and then we're going to say successful withdrawal. Otherwise, we're going to print out insufficient funds. So let's try that quickly in here. So now we know that we'll work with Siobhan's account here, and we'll work with the BA1 one. So I'm just going to comment that one out for a sec. I'm going to give Siobhan some money. So I'm going to say BA1 dot deposit, and I'm going to give her €100. Then I'm going to withdraw some money. I'm going to say BA1 dot withdraw, and I'm going to withdraw 90. And what do I expect that time when I withdraw it? I'm going to expect to say it's successful. And then I'm going to try and withdraw again. Try to take out 900, which is too much, and we should get an error message there. Oops, and we didn't. Excellent. Why didn't we? Oh. Do as I do, not as I do, as I say, not as I do. So our withdrawal returns a string. So we need to deal with what it's returning. So remember, our withdrawal returns a string. So I never dealt with that string. So nothing was happening to it. So it did what it was supposed to do, but we never got the message. So we'll try it again this time. So you can see here, we took out the 90 and it said successful withdrawal. And the next time it said insufficient funds when we tried to take out the 900. So for those of you who are wondering what happened there, when I called the withdrawal, it returned the value, but I never dealt with that value, so therefore nothing happened. Here I'm dealing with it. I'm saying print out whatever is being returned from this withdrawal. Okay, so again, when you're doing these exercises, I want you to have a look and see what happens. So you can see that when I code, I make mistakes, and that's normal. And that's why when you're doing the exercises, it's much better to make the mistakes and see where you're going wrong than it is to copy and paste the code that we give you and get it right the whole time, because you don't learn anything from that. So have a play with this when you're doing it. Try and get it so that you can see if it makes a mistake, why did it make a mistake? And if you don't understand why it did what it was doing, just throw it into Slack and someone will answer. Okay, let's keep going here. So the this keyword. So the this keyword is another important keyword in our in what we're doing. So I just got rid of me. Don't need to see me. So when we talk about this, we're talking about this object. So this object. and we will write this keyword inside of our class. So in here, when we created our 3 fields, we had name, account number, balance. I didn't put the keyword this in front of these, even though I'm saying make this object's name equal to whatever's passed in, make this object's account number equal to that, make this object's balance equal to that. I could have if I wanted to. I didn't, because there's no ambiguity there. It knows that name is my field. It knows account number is my field account number. It knows balance is my balance. Okay. So you can see it takes those 3 values and it pops them into name, pops them in here. Sometimes it'd be nice to name the parameters passed in as the same name as the instance fields. So what that means is, instead of trying to come up with new names for these guys here, I just give them the same names. Because then, wouldn't that make it much easier to understand? I'm passing you in a string for the name, I'm passing you in a string for the account number, I'm passing you in a double for the balance. It'll make it much easier to understand. So, but if you do this, okay, we need to introduce a new concept to deal with that, because now we're name overloading. We're using the same name more than once in a different way. So if we have the same name, Java doesn't know which you're talking about. Are you talking about the instance variable, or are you talking about the parameter that you're passing in? So if we pass in name, account number and balance, they're the same names as the field names. If they're the same, we have to use the keyword this. So what we're saying is, make this object's field name equal to the name that's being passed in. So in this case here, this name here is this name here. They're the same. This account number here is this account number here. They're the same. This balance here is this balance here that's been passed in. They're the same. This object here, there are fields. So this name here is here, but when we use the keyword this in front of it, we're talking about this object. So we're talking about the instance variable, the field. Okay, so it refers to the current object's fields. So you can see here that these values here are the values that are being passed in by the parameter, and when we use the keyword this, we're talking about the fields. So this name, oops. So this name, this account number, this balance, there are fields. So in the statement, this.x equals x, this.x refers to the object's property field, and x on its own is the parameter it's passed into the method. Okay, so if we want, we can use different names for our parameters, and then we won't have any issues. But when we use the same names and we overload the names, it's easier to read, but then we have to use the keyword this, and this stands for this objects. Okay. So there's our version 7. We haven't made any changes to our class diagram. We've just changed the names that are being passed in. We're passing in a string, and a double. That doesn't change. What we changed was what we call them in the class. Okay, so our calling program, it doesn't matter. The calling class doesn't matter. It sees exactly the same constructor. It sees a constructor that expects a string, a double. How we have written it in our bank account class is up to us. Okay. So in summary, our bank account class now has actions and behaviours. It has fields, so it has data, it has methods, actions and behaviours. Constructors handle how the objects begin, so how we set up the object, and methods handle what it can do afterwards. So that's the behaviour of the object afterwards. So constructors set up your objects in different ways. So again, we said that we had default constructor, and then we have constructors that we pass information into. Overloading gives flexibility depending on the information you have, and methods define the behaviour once the object exists. So that's what happens, how we use the object afterwards. Okay, so quite a lot in there again. But again, the exercises should give you a little bit of a help with that. Okay, so let's have a look at our last guy here. Okay, so was it last week before Easter, or not before Easter, my God, I don't even know what month it is. The last week before midterm and before Halloween, we were looking at arrays, and we said that an array was a space in memory that could store many things, many elements, and each element was the same type. So we were setting up our arrays to store numbers, and we were able to set up an array to store strings. So we're going to have a quick tour back of a reminder of what an array is, and then we're going to go on and we're going to have a look at arrays of classes. So arrays can store any type of data, and again, I liken the whole area of the arrays to your house and a row of terraced houses, and each house has its own number. So if we have a postman that wants to deliver an envelope or a letter, or in my case, I got a really good sweeping brush yesterday and I'm very excited, and the post person delivered my new sweeping brush. So if the post person is going to deliver something to our house, they need to know what number they have to deliver it to. And that's the same in our array. So our array has indexes, and the index will tell us where the element is at. So we can store any type of data, and we will be able to tell it how big it's going to be. So in this case here, we're creating a space in memory called numbers. Each element in our number is going to be an int, and it's going to store 10 of them. And we said that when it stores an array, again, I write them like this. It doesn't matter what way you write it. You could do it the other way. And I've lost count already how many I've got. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is our array. It's called numbers, and our index starts at 0 and goes to 1 less the size. So that can store 10 numbers. So that's the equivalent of, I'm not going to store 10 houses. And each house has a number. So our array has a name, it has a size, and it starts at 0, its index. Okay. But it can store any type of data, but each element will be the same type. It can also store objects or classes. So in this case, it's storing an array, and each element in the array is a string. In this case here, it's going to be called friends, and each element is a person. Okay. So when we create our array, we said that we tell our code that it's an array, so that's our square brackets. Each element is an int, that's our data type, and it's called numbers. When we declare it like that, it creates a space in memory that's going to point to an array. But at this stage, it hasn't created anything because it hasn't built it. We've said before, until we have our new keyword, then nothing is getting constructed. So now we're creating a space in memory that's going to store our 4 integers. Okay, and that's our index numbers, 0, 1, 2, and 3. Starts at 0 to 1 less the size of our array. If we want to access a number directly, we use our array name and then our index number. And into that element, we're putting the value 18. So that's our array name. 2 is our element number. Oops. Okay, I'll just do it on this one, sorry. So 2 was our element number, and we were placing the value 18. Here into our array numbers at element 0, we're putting the value 12. So we're setting the element at index 0 to 12. These are primitive data types. It's only storing one number. So if we overwrite it, then we will overwrite that number. Okay. If we want to print it out, it's system.out.print the name of the array and the index number we want to print out. So therefore 18 will be printed to the console. So we saw that before our midterm break. So we also saw how we could create an array of strings. So again, we use the keyword string, our square brackets, and then we give it a name. So in this case here, we're creating a point or a space in memory that's going to point to our array. At the moment, it's not pointing to anything. So it doesn't have any address there to point to because we haven't constructed it yet. Here we're constructing it and we're saying that it's going to have 4 elements. And each of those at the start is null because we said that when an object is created from a class, until we initialize it with values, it's going to have the null value. So at this stage in time, we have an array that can store 4 strings and it has 4 null values. And then if we want, we can put the string dog into element 1 and the string cat into element 3. So now we have null, dog, null, cat. Okay, so again, I know string is a class, but now we're going to learn how to use our own define classes and have an array of our own classes. So in this case here, we're creating our string array. And so remember that you can either put the array at the square brackets at string, and that would be an array of string called words, is how you say it. Or in this case, a words array, each type is a string. And I think in Java, the default should be string square bracket words, but again, it doesn't matter. So we're creating our words array. It's going to store 4 strings. This is where we're constructing it in memory. So again, the use of the new keyword. We're putting values in, and then we have our for loop. And we're saying for int I is equal to 0. So remember what that's doing. It's creating a variable in memory. It's calling it I. I is just a name that we're giving it, and we said we call it I because it's close to the index finger of our right hand, so it's easy to hit. I is less than words.length. Words is the name for our array. Our dot operator, and again we're seeing that, we learned about it today. So this is the length field of the words array. So that's a field, and that stores whatever value is there. So how many elements are in, how many elements can be in our array. So that's going to be 4 I++. So every time it's going to add 1. And then it's printing out whatever is in our words array at element I at, so it'll print out whatever's at 0, then at 1, then at 2. So it's going to print out null dog, null cat. Okay, so we had a look at that before, but we haven't had a look at the array of objects. So again, our array can store any type of data. So these are our primitive, these are our objects that come with Java, so are part of Java. And then these classes are the ones that we write ourselves or we get from somebody else. So we find them somewhere else. We might find code in GitHub that we want to use. We might find code somewhere else, but we write them ourselves and we include them ourselves or whatever it is. So this one here is a class that we're going to write ourselves called person. So now you can see our class diagram. Again, this class diagram might be something that you're given. It depends on what methodology we're using. So we will, when we're giving you diagrams, we will use something similar to this, and it'll give you the definition of what we want you to call it and what the fields are. So you can see here that this is our person class. We tell you what the class name is. So that's our class name. We tell you what the fields are. So, and we give you the data type. So the field name is age and it's going to be an int. The field name is first name. It's going to be a string, second name string, float, temperature, etc. So there are going to be our instance variables or our fields, the attributes. Then we have our behaviors. So we start off here with our constructor, and in this case we're creating a constructor that needs to have 3 pieces of information. So the 3 pieces of information are going to relate to the age, the first name and the second name, and we may be giving a default for the temperature. I don't know, we'll have a look at the constructor when we get it. Again, you're going to be told that. So the constructor expects 3 pieces of information. We're going to give it 3 pieces of information. The 4th piece of information that's going to be here is going to have some sort of a default. Then we have our methods. So these are called our getters. We're going to learn about those next week. We have our setters, because these guys here should be all private. And we're going to learn about data hiding and how that relates to encapsulation. So these guys here are going to be private. These with the green dots are all going to be public, so they can be accessed externally. We'll have our getters, which get the value, our setters, which set the value, and then we have other methods which do other things. So this is the way our code is kind of going to be written. Our fields, our constructors, our getters, our setters, our other methods. These are the behaviors of our class. When we create our array, we tell it it's going to be an array of, so our square brackets. Each element is a person. We're giving it a name. Okay, at that moment in time, nothing has been constructed. Now we're telling it that it's going to have 4 elements. Again, they're all null because we haven't created any of them yet. So we haven't constructed each individual element. We've constructed the array, so we have our array in memory, but each element is null because we haven't given it a person yet. Now, if we want to give it a person, we have to create a new object. So into our element 1, we're going to place, now it's going to do it, our new object, our new friend, so that's supposed to be a person, and it's going to be Joey. So that object there is going to go in here into number 1. And the rest are null because we haven't constructed those yet. So think back a few seconds ago, we said int ages equals new int 4. So that's our array. And then we said ages 0 equals 12. So into element 0, put the number 12. That's what we're doing here, except each element is an object. So we have to construct the object that we're putting into our array element. Okay, so you can see here into element 1, we're putting Joey Tribbiani, he's 25, and then this temperature, which we're going to give some sort of a default for because we don't pass it in. So now when we want to print out something, so if we go back here for a sec, when we wanted to print out the string, we just said print out words I. So print out whatever element is stored in our array at element 0. Here we're saying print out whatever is in our friends array at whatever element we're looking for and give me the method. So it's calling the method print first name. So we're saying print our array friends at element 0 and get me the method first name. So this guy here is going to print all of them. So let's go through it line by line what's happening. So our method is called print friends. We're saying if size is equal to 0. What that's saying is that's telling us that we have a variable or field instance called size that's storing how many elements have been added into our array. Now we haven't done that yet, so we'll do that our next time, but what that's doing is it's keeping track of how many elements are in our array. This is a variable, an instance variable that we've created ourselves. So if that's 0, it's no friends. Otherwise, we're going to go through each element in our array. So I is equal to 0, I is less than friends.length. Remember, friends.length, friends is our array. The .length is a field that belongs to that array, and it's going to keep track of how big our array is. And then we're saying I++, so every time it'll add 1. And then we're saying in our array at element 0, first time, call the method print first name, and it'll do whatever it's supposed to do. At friends array 0, call the method print second name, and it'll print the second name, and so forth. So you can see here that we're bringing in lots of the things that we've learned today. Our dot operator, our behaviors, and we're bringing it into our array. Okay, so if we want to have our list of friends, so this one here is public. It's returning a string. It's called list of friends. It doesn't need any information because it's using all of the information that's inside the object. So what it's doing here is it's creating a string called list of friends. It starts off with list of friends \n. So what that means is the rest of it is going to be written on the next line. And then we're saying go through our friends array and make the list of friends equal to whatever's currently in it. So list of friends plus get me the first name and the second name, and then go on to a new line. And then when you've finished the for loop, return that list of students. Or sorry, list, it's only a name. So return that list. And that'll return the first and second name. So you can see here, I've called this list of students, list of students. That's just a name. I know it doesn't make sense because it should be, you probably think that should be list of F or friends or whatever it is. And it should be. It might make more sense. But it's just a name that we've created, a space in memory. We've called it list of students, and into that we're putting this information. And then we're returning it back to whoever's calling it, and it's going to use it. Okay. So when you go to your exercises, we'll get you to do something like that. So I wonder, could I do something quickly like that with our bank account? Okay, I don't want to do that because it'll make things slightly more confusing. Okay. So I'm going to create I'm going to just keep going here, and I'm going to do it from a procedural point of view. This code here, as regards putting it into a method, I'm not going to do that for this because I'm going to create my array inside my main, just to show you how you would do it. And then what we'll do is on another day we'd show you that we would create another class. That class would have the array of bank objects, so that would be called the bank. So we'd have our bank account class. We'd have another class called bank that would have an array of bank account, and then we would have our class where we'd have the input and the output. Okay, so we're not going to just do that for time being. Okay, so let's, in here in our main, just create quickly a bank account, a bank. So we're going to say, bank account. So it's an array, and we're going to call it bank. And we're going to say it has just two people in it. Okay. And so now we've created our bank account. And now I'm going to say, bank 0 equals new bank account, and we're going to say I don't know, Donald Trump. His account number is 1, 2, 3, 4, and if I could put a minus in, I'd probably put a minus in for him because I'm not sure how much money he has. Lots. Anyway, so we just leave it at that for him. And then into our another one. So into the first element, we'll put a new bank account, and we'll put Melania. Okay, so now we've created our array and we've created 2 bank accounts. So now if I wanted to, I could have a little for loop. So remember why we're starting at 0. We're starting at 0 because our array always starts at 0. I is less than, I could say 2 because I know it's 2, or I could say bank dot length, because length is a field for the array, and then I++. And then I'm just going to print it out. So I'm going to print out the bank details. So I'm going to print out my bank here's my square brackets, I dot display. So what that'll do now is that'll go through each element in my bank account and it'll display it. So let's just and we'll just run that. Oh, I must have left one in. Oh, sorry, I left that one in. Just take that out for a sec, sorry. So you can see here that it's created my bank account, and it then went through each of them and printed them. So let's say, for example, I wanted to make the names uppercase. What I can do is I can go back into my bank account. I can go to my display. Name is a string. I could change that to uppercase. See all these guys that are after popping up? They're all methods that are available to my to strings. So if I said something like that, so now you can see it took the Donald Trump and it made it all uppercase. It took Melania and made it uppercase. If I wanted to, I could change this so that it was to 2 decimal places. And we can, I'll give you the code for that another day because it's a bit confusing. So, but you can have a play with this as you're doing it. And again, it's in your exercises. So if nothing else, if you just take from this past 2 days, that from now on, our code, we're going to be writing our code in classes. Okay, so we're going to write our code in classes. We have been doing that all along, but we're really going to start using our object-oriented programming principles as much as we possibly can. So Monday, we looked at classes and objects. We looked at properties, so fields, variables, attributes. We said that the data that it stores is the fields, is called a field. And another word for that might be instance variable or attribute. We talked about the methods, and we said that the methods were the behavior. They're the things that the class can do. So when we looked at apple, we said that in a fruit, the apple fruit, not Apple, the company, we said that it had a name and a weight. They were its fields. They were the values that were going to be stored about each individual apple. And then each individual apple had behaviours, and those behaviours were like rot and fall and whatever else it was. So they are the things that the apple could do. We talked about the dot operator and how we said the dot operator was our way of accessing an object's field or invoking an object's method. We created our first account, our first class, which is our bank account, and we brought that bank account on Monday right through to the declaration of it as a class, the adding of the fields, so the adding of the properties, and then we looked at the default constructor. Today we looked at the behaviours. We added deposit and withdraw, display, and we looked at how to create an array of objects. So how classes and objects, or classes and arrays, work together. And again, that was our class diagram. So a lot done. The exercises are up on our 2 books. Give them a go. Just try and understand what it is that you're doing and keep it in your head. What would if I had to model something, how would I model it? If I was asked to write a project for the local car showroom or for the local library or for the local college or whatever it is, or for a buy and sell in your area, or, you know, meeting new friends, if you wanted to have like some sort of friends or, you know, app. What would I need to model? How would I create my classes? What information would I need to store about those classes? How would the objects work together? Because that's where we're at now. We're at how do our objects work together, and we're using all the coding principles that we've learned so far to get them to work together. Okay, I think you've done enough. I think you've listened to me for far too long. So we'll leave it at that. We'll see. I'll be online tonight between 7 and 8. If anybody has any questions, just give us a shout. And again, we're always on Slack, and keep up the hard work on Slack. All you that are answering questions, it's really, really appreciated. And we'll see you next Monday. Over and out. Bye-bye.